What's up, everybody? So in this video we got a bunch of things that we got to cover, including climate change, greenhouse gases, greenhouse effect, all these bunch of things like precautionary principle. So there's a few things, okay? It's a bunch of things we got to get over, but once we get through these things, hopefully it will make a lot of sense, and that's all you got to know for this chapter on climate change. Okay, so let's just get started. Now, I want you to think about our Earth, right? Isn't it amazing that our Earth is exactly the right temperature for us to survive? Imagine the Earth was 20 degrees warmer or 20 degrees colder. All of a sudden, a ton of organisms would just go extinct, right? So it's important to understand that our Earth is actually a perfect temperature, okay? A perfect temperature for all organisms and plants to survive and thrive, right? So bear this in mind. Now, I want you to think about how the Earth is maintained at this so-called perfect temperature, or this temperature that we can all survive. So to make you understand it, we're going to talk about a greenhouse, and then I will talk about the Earth, because it's very, very similar. So picture this. What is this right here? This is a greenhouse. So a greenhouse is basically a structure or a kind of a room made of glass, mainly glass. Maybe you've seen one, maybe you haven't, but whatever. Maybe you can think of a room, maybe you have a room somewhere in your house that's like very much like it's got mostly windows. And so during the summer, you find that that room gets crazy hot compared to any other rooms, okay? So that's basically what a greenhouse is. It's a room made of glass that gets warm very, very easily. And we're going to explain exactly how so. Okay, so we got this. Normally, I have a room like this where I like dry my clothes in because it gets very warm. Okay, maybe you have something like this, maybe you don't. It doesn't matter. So let's picture this. We got the sun, okay, and we got this greenhouse. We got these plants inside the greenhouse. Now, the sun is going to emit heat, right? Heat. This heat is released in the form of a wave. Obviously, our eyes cannot see this, right? We cannot see this wave, but it's a wave. So heat is emitted, or light is emitted in forms of a wave. So we're going to call this particular wave emitted from the sun by a specific name, okay? Short wave radiation, because it's a wave that has very short waves, like they repeat very quickly. You know, like you can have a long wave that goes like that, or you can have short wave like this one. Now, it radiates, so it gets sent towards here in all directions, right? We're only taking one of its rays. So here goes one of the rays, and it goes towards this greenhouse. Now, this glass is going to do something to the shortwave radiation. So it's going to change it into long wave radiation. So notice how this shortwave radiation, as soon as it passes through this glass, the glass allows it to pass through, but as it passes through, this shortwave radiation becomes long wave. Notice the wave is now longer. Okay, I'll put the name here. Now, long wave radiation is slightly different from short wave radiation. Why? Because now let's say this long wave radiation is going to now bounce around, it's going to move around inside this greenhouse and try and escape, okay? Because light and heat likes to move in all directions, right? So now some of this long waves are going to try and escape. So look here, it's going to try and move around, try and pass through this window. But guess what? Long wave radiation doesn't pass through this window, doesn't pass through this glass, because glass is impermeable to long wave radiation. It is permeable to short wave radiation because the short waves pass through by becoming long waves, but this long waves does not pass through this glass. That means that all these long waves, or all these heat waves, are now building up inside this greenhouse, causing the greenhouse to be warm, warm and warm and warm. It makes it warmer and warmer and warmer, right? Okay, so that's the greenhouse. That's how it works with a greenhouse. Now, I told you. Okay, here's words basically summarizing what I just said. Now, I told you. I told you that I'm going to tell you this story because it applies to the Earth. So how exactly does this concept apply to the Earth? So let's just go to this picture. So now, this was how a greenhouse works. So we call this effect that the greenhouse has of heating things up like this. We call it the greenhouse effect. And I'll show you exactly how it works on Earth. So here we have the sun, and here we have the Earth, right? We got all the continents, we got the oceans and all that, right? Now we also have clouds here, and we have this layer here around the Earth. This layer here we call the atmosphere. Okay, the atmosphere is made up of many layers, including the stratosphere and things like that, right? But you don't need to worry about that. Now, The atmosphere is made up of gases, okay? Gases like oxygen, carbon dioxide, many gases. So I'll list a few here. So we got carbon dioxide, we have methane. Remember, methane is a gas that is released from like burning fossil fuels or from cows naturally. All of these kinds of things. We got water vapor, right? Which is just a gas form of water. We got oxides of nitrogen, which can also be released when you burn stuff. Hydrofluorocarbons, I'll talk about this one later. So the point is, in our atmosphere, there are a lot of gases. Bear this in mind, okay? Now, let's go to this point. So the sun, what does it emit? Tell me, what kind of radiation? Shortwave radiation, right? So it emits the shortwave radiation towards the Earth. Now it reaches the Earth. It passes through this atmosphere as shortwave radiation, and it reached the Earth. Now, the Earth may absorb some of it, making the Earth a little bit warmer, slightly, and some of it may get reflected, okay? Now, the Earth will reflect it as long-wave radiation. Okay, that's interesting. So this is very similar to the window idea in this thing, remember? The window changed this short-wave radiation into long-wave radiation. Here, the Earth reflected the short-wave radiation as long-wave radiation. Okay, cool. Now what? So now it's reflecting it, meaning it's trying to go out of the atmosphere. But guess what? This atmosphere has these gases. These gases don't allow this long-wave radiation to pass through it. Therefore, as soon as the long-wave radiation enters the atmosphere, the gases catch it and send it back. It basically absorbs it and sends it back. This way, all this long-wave radiation stays inside the Earth. It stays on the Earth. It doesn't leave through the atmosphere. So it builds up and makes the Earth warm. Now, the gases that are responsible, so I'm going to put this summary here. The gases that catch this long-wave radiation and prevent it from leaving through the atmosphere are called greenhouse gases because they cause this greenhouse effect. Okay, so in summary, this is a greenhouse and it has this effect of heating things up by turning short-wave radiation into long-wave radiation, trapping it inside the greenhouse. When we apply this concept to the real Earth, we call it the greenhouse effect because there's no greenhouse right here. The Earth is not a greenhouse, but it behaves like a greenhouse in retaining this heat. Okay, so we call it the greenhouse effect. Now, the gases in the atmosphere responsible for trapping this heat are called greenhouse gases. And examples include carbon dioxide, methane, water vapor, all of these that I mentioned, okay? Carbon dioxide and methane are the very key ones that are more important when we think about them. So oxygen, for example, is not a greenhouse. That's why I didn't mention greenhouse gas. That's why I didn't mention it here. So these right here are specifically greenhouse gases. So bear in mind, in the atmosphere, there are other gases, but I mentioned the key ones right here for the greenhouse effect. Okay, great. So before we move on, I just want to real quick talk about this one, hydrofluorocarbons. Okay, we're going to come back to this image because we need to move on in terms of a different direction. But just because you kind of need to know what this one is, okay? It does pop up sometimes. So basically, a while ago, you know what a fridge is, right? Fridge is, right? You store your food there. Hopefully everyone knows what a fridge is by now. Now, a fridge has, in the past, they used this gas called a chlorofluorocarbon, CFC. Okay, this gas was used, or this substance was used in refrigerants. So it was used in the process of making refrigerators. But it was found that this gas, okay, very important, contributed to ozone damage, okay, ozone damage. Okay, I'm not going to go into detail on this because you don't need to worry about it much. Now, so they stopped using this. So they stopped using this because it caused ozone damage. So instead of using these CFCs, they use HFCs. So not chlorofluorocarbons, but hydrofluorocarbons, okay? And these had another problem. So they solved this problem. They didn't cause ozone damage, but they caused the greenhouse gas. They are a greenhouse gas, so they cause the greenhouse effect. So the problem is that normally, so we'll get to this, normally this gas doesn't exist inside the atmosphere, but because of this creation, we put now more of it. And so if there's more of it, we're going to trap more heat, and that's going to increase the Earth's temperature more than normal, okay? So that's why that's a bad thing. So at the end of the day, we don't want to use either of these. Now, real quick, note that the damage to the ozone layer is not because of the greenhouse effect, okay? It's because of other molecules. So CFCs, HFCs will not cause damage to the ozone, okay? So note that they are different things. Damage to the ozone layer is not a cause of the greenhouse effect or increased global temperatures. It is other molecules that cause ozone damage. Don't need to worry about this much. I just thought I need to mention it. Okay, now my question is this effect bad? Whatever you said was right. It could be good or it could be bad, okay? Good because without this effect, Earth would not be inhabitable. It would not be habitable. There would be no organisms that can survive because the temperature would be way too cold. So it's good because it allows us to survive here. But it's bad because of one thing. Let me show you. So 200 years ago, okay, this is the carbon cycle of 200 years ago. I'm not gonna go into much detail here. This is an image I used in another video. But basically, look here. In our atmosphere, we have carbon dioxide, one of the greenhouse gases, and volcanic activity, respiration from humans, animals, and detrivores and saprotrophs contribute to carbon dioxide being released into the atmosphere. And then photosynthesis helps to remove carbon dioxide from the atmosphere. The ocean helps to uptake some. So you can see that there's this balance between releasing carbon dioxide into the atmosphere and taking it away from the atmosphere, okay? Now, this is in a balance. So these are balancing each other out, okay? Because when organisms die, they turn into fossil fuels, which stay underground and so on, right? But now, what's different? Now we burn these fossil fuels. 200 years ago, we did not burn these. So these fossil fuels are storing carbon in them. And when we burn them, they're released as carbon dioxide. So 200 years ago, we left them in the earth, so they couldn't be released. But now we take them, we go to factories, and we burn these fossil fuels. So now we release way more carbon dioxide than the normal equilibrium, than the normal balance. Okay, and in addition, we cut down trees, and guess what trees do? They take up this carbon dioxide, removing it from the atmosphere. So we are doing two things that are upsetting this balance of greenhouse gases. We are releasing more by burning these fossil fuels that are in the soil, that are not meant to be released, and we are chopping down trees which are taking them away. So all in all, we're increasing their levels of carbon dioxide. Now, why is this? Why did I mention this? Because guess what? Carbon dioxide is a greenhouse gas, okay? And a greenhouse gas is going to trap heat. So if we have more carbon dioxide than normal in the atmosphere, we're going to trap more long-wave radiation and hence make the Earth warmer and warmer and warmer. And too warm of a temperature is also bad. So cold is a bad temperature, but too warm is also bad because now the ice is melting, certain organisms are dying, and there are many effects which I'm going to talk about in this video. So to answer this question, it is both a good thing, but it can be a bad thing, and it's becoming a bad thing because of the way we are treating our Earth, okay, in terms of our greenhouse gases. So I hope that makes sense regarding the big concept. And I want to show you here some data because it helps to show this idea. So look at this. Year 1000 to the year 2000, so 1,000 years, okay? And the x-axis is the years, so as the time goes on, and the y-axis is the amount of carbon dioxide in the atmosphere. Don't worry about this unit, just think amount. So for a long time, the amount of carbon dioxide in our atmosphere is very stable. Look, it's like going up and down, it's kind of stable, until a point in time around here, after the 1800s, when we started making things. We started burning fossil fuels to make heat, to invent things, right? So this is called industrialization, when we try and innovate, we try and make factories and buildings, okay? And by doing this, we basically cause a huge change in the carbon dioxide level because all of this industrialization leads to increased carbon dioxide emissions, right? We're releasing more and more of this carbon dioxide from the burning of fossil fuels and innovation, right? It's a part of our evolution. But it's becoming bad now. We released way more than we should have, and it's basically going straight up. Okay, so this is a greenhouse gas that is now contributing to global warming. So we can also look here at another data that's specifically from like the 1950s that shows increase. So it's still increasing. even very recently up until now. So you can see it's a very bad thing that is not looking like it's stopping. So it's good to see this data so you can understand a little bit the concept. Okay, so we just explained that, okay, let's go here. So I just explained how the greenhouse effect works, and that we as a human race are amplifying this effect by increasing the amount of carbon dioxide, oxides of nitrogen, which is caused by burning things, and methane also caused by burning things. So we as civilization are increasing these greenhouse gases, and hence increasing the greenhouse effect, and hence in contributing to global warming, which is the process of the Earth getting warmer. Okay, so global warming, which I just said, is the rise in the average global temperature. Okay, so why is this a bad thing? Okay, so why is it important that our temperature does not increase? Many reasons. Let's start here. Increase in photosynthesis. What is happening because of global warming? Because of global warming, we have more carbon dioxide in the atmosphere. Guess what? Plants like to use carbon dioxide to do photosynthesis. So plants will do more photosynthesis. That's one thing that's going to happen because of global warming. Another thing, here we have some ice. Ice likes cold temperatures, otherwise it melts, right? So because of increase in temperature, ice will melt. When ice melts, the frozen soil under that can melt, and things can be released into the atmosphere, okay? Like detritus, and we'll talk about that later. But things can be released, and that kind of creates a vicious cycle, but we'll talk about that later. Don't worry about this. Just ice can melt. When ice melts, there's deadly consequences, right? Certain animals depend on ice, like polar bears. Now, when ice melts, what happens? Okay, think about this. When you put a lot of when you put ice into water and it melts, the cup will get more full, right? As it melts. It's the same thing here. So when you have an environment that's full of snow or ice or things like that, when it starts melting, the sea levels start rising, right? Because when the sea is full of ice, like in the Arctic and places like that, because of the temperatures rising, the ice is now starting to melt. And when the ice starts to melt, the water levels in the oceans will start rising, because when ice melts, it becomes water. So the water levels now start rising. This means areas that before were not underwater are now starting to become underwater because the sea levels are rising. Okay, very important to understand. So a lot of places which had houses on islands that were safe are now not safe anymore because the sea levels are rising, and now these places are going underwater, and so basically flooding is happening. And then lastly, because of this global rise in temperature, we are seeing changes in climate. So there are increased winds or changes in wind patterns and ecosystems and all these kinds of things. So temperature is affecting climate change. The different aspects, not just temperature, is being affected. So notice how I said for the definition, it's a rise in average global temperature. That's important because of this greenhouse effect, not only are we increasing the temperatures of some places, but we're also decreasing. Climate change is also accompanied by decreases in temperatures in other places. So the important word to understand is that global warming is the average rise. Overall, the Earth is getting warmer. Some places are actually getting colder, where other places are getting warmer, but overall it's getting warmer. Okay, but not everywhere is getting warmer. Just overall it's getting warmer. So make sure you understand that. And that's why this word or this phrase is rather tricky to use, okay? Okay, so I just said there's a lot of effects that can happen due to global warming, right? Due to this increase in temperature. I listed a few here, a lot of things that can happen. Now we need to specifically consider two kinds of ecosystems, coral reefs and the Arctic, okay? We gotta talk about these two in a bit of detail because they come up the whole time on exams. So let's talk about the coral reefs first. So coral reefs, you know these, you can Google some images because here I have a cartoon, but it's basically these little corals under the ocean, right? They look beautiful, they can be different colors, and they're very hard. You expect them to be soft when you touch them, they're like rock hard, okay? So this ecosystem is very sensitive to rising CO2 levels, okay? Rising CO2 levels. Why? Okay, first of all, What is this thing? So this thing is basically an organism that uses calcium from the ocean. So calcium is like a little molecule floating in the water, and it uses it to make the skeleton that we call limestone skeletons, which is rock hard, okay? Now, there are various things that can happen. One, this. Because of increased carbon dioxide, what happens in our atmosphere? Because of increased carbon dioxide in our atmosphere, we have increased global warming, right? Increased temperature. Increased temperature has a huge effect on coral reefs. It causes those coral reefs to release algae, which is like little organism. So it releases these algae from it. And these algae causes bleaching, whitening of this coral reef. And this is very bad because they can almost never recover from this. Okay, so the increased temperature causes increased release of algae, and this causes bleaching. They call it coral bleaching, whitening. And this is extremely hard to reverse. So in essence, they die from this. Okay, so that's why this is very bad. And another thing is, let's look at another thing. So I can just emphasize this. They die. They can die from this. And so we're losing this ecosystem. Let's look at this one. Okay, so here, remember, we have increased carbon dioxide. So here we have this, pretend this is carbon dioxide. Okay, high CO2. High CO2, remember, one of the things in our carbon cycle is ocean uptake. So CO2 can go into the ocean. So if we have more CO2 in the atmosphere, more will go into the ocean. Let me go to this. Okay, so more CO2 in the atmosphere, more in the ocean. Now, CO2 dissolved in water creates an acid, okay? An acid. Acid is bad for these coral reefs because it prevents them from being able to do photosynthesis properly, okay? Acid is bad, prevents them from doing photosynthesis. And because this thing can do photosynthesis, now it will die, okay? So, well, actually, let's put it different, okay? So high CO2, right, is used, it causes this acidity, right? And because there's a lot of plants in the ocean, the plants struggle because now the water is not neutral anymore. Now it is very acidic. And so because of this acidity, they cannot do photosynthesis properly anymore. So a lot of plants will die. A lot of plants will die from this. And if a lot of plants die, guess what? The whole food chain will get affected. So now the consumers may not find enough food and they will also die. And in addition, these coral reefs, like I said, they extract calcium from the water to build these limestone skeletons. Now acidity can affect this process and therefore they cannot form properly. So their coral formation is very disturbed. So then they end up looking like this instead of beautiful like this. Okay, one more thing important to consider is this. Let me move this here. So ocean acidification. So they basically die. They cannot form properly. Now, last one. Remember how I said increase in global temperatures. Okay, first of all, increased CO2 levels leads to increased greenhouse effect, which means increased global temperatures, which means increased what? Melting of ice, which means what? Rise in sea level. So rise in sea level means that these things are now deeper, right? They're now deeper than normal. Have you ever noticed if you've gone diving or something, scuba diving or something, the deeper you go, it gets really dark. You can almost not see anything. So you go down to look at all these things, but it ends up being so dark you can't see anything in the first place. So these things end up going so deep so that they now have very little sunlight. Now, they depend on sunlight because remember I said they can do photosynthesis. Now, because they have no sunlight, they cannot do photosynthesis anymore, so they end up kind of struggling to survive and they die as well. So this is crazy, right? This is one ecosystem that is severely affected by this climate change, this global warming, okay? You can see this increase in CO2 levels. Now let's look at the next one, which is the Arctic. So if you can understand these three ways in which the coral reefs affected, you're good to go. Now the Arctic. The Arctic is an ecosystem that is made up of, like it basically is two basic kinds of environments. One, sea ice, and two, tundra. Let me show you a picture. So this, we know this. When we think of Arctic, we think of the ice and the polar bears and all that. Now tundra is basically the environment where there's no ice, but it's an extremely cold place, like in the Arctic. So it's like this. It looks like this. Okay, there's grass. It kind of looks like land, right? So that's tundra. So tundra is a place where it's really freaking cold. It's freezing, but there's no like ice is not the main thing, right? This is the main thing where ice is, and now this is tundra. Now, if you dig up tundra, so if you take a spade and you dig here, you can dig out some frozen soil, basically, which is called permafrost, okay? And it's basically permafrost is soil that's been frozen, or not soil, but it's like material like soil that's been frozen for like many years, okay? And inside it's got a lot of carbon and stuff stored, okay? Bear this in mind, that's important. Okay, so let's go here. So here we have it, sea ice, tundra. Inside tundra, you can find permafrost. Okay. Now the biggest thing is, right, melting of ice. Increase in global warming causes melting of ice. Melting of ice can affect our ice. Let me show you. Let's just put it like this. Can affect polar bears because why? Because why? Because why? Let me show you. So increased. Let me show you. Melting of ice can cause this effect. Melting of ice means that polar bears, it destroys some of the polar bears' environment, right? And they depend on ice, okay? So this can affect a lot of animals that depend on ice. But not only this, notice here, we have these plants growing under the ice. So they depend on the ice where they grow. So if the ice starts melting, then guess what? We start losing these algae. Okay, so these algae, these plants are growing under the ice, and because the ice is melting, now we have less algae. Now, so let me show you. Let's delete it. Oh, sorry, wrong one. So we delete the ice, polar bears affected, the algae cannot survive because there's no ice for it to survive on. If algae cannot survive, certain organisms that need to eat it cannot eat, so those organisms die and the whole food chain is affected, okay? Very important. Another thing is melting. So remember how I said there's tundra, right? Tundra is basically like, it's like the soil version of this Arctic environment, okay? Now I said there's permafrost inside, permafrost, right? Which is like this soil that's frozen for many years. Inside of it, it's got a lot of carbon. So when melting happens, this permafrost gets melted and releases this carbon as carbon dioxide. And guess what? Carbon dioxide is a greenhouse gas. So this kind of makes this vicious cycle. So now there's more carbon dioxide in the air, which means more global warming, and it's just terrible. Okay? Now also, because this environment is changing, so it's getting warmer, organisms or pests from other ecosystems can migrate. So now this area where there's normally no certain organisms, now these organisms can come here and take over this environment. So there's migration. So that's another way in which this global warming affects the Arctic. Okay, so what have we covered now? So overall, as a summary up till now, we covered what the greenhouse effect is and how that increases the global temperature, right? We talked about how our actions nowadays are increasing the greenhouse gases, and therefore we are increasing global warming. We have talked about how global warming has certain key effects, okay, such as these. Then we have talked about how global warming specifically impacts two ecosystems, including the coral reefs and the Arctic. Okay, you need to know these two. Now, we're kind of getting to the end now, but it's still important, this stuff that comes up in the exam, so we've got to bear this in mind. But this part, I would say, is fairly logical, but you need to just see what I mean. So here we have a critique, right? Forgot his name a little bit from Ratatouille. What's his name again? Whatever. But I know this guy's name. It's Remy. Okay, so the critique asks now, okay, why do we care about this? Why do we need to put an effort to end this global warming? Why? What's the point of reducing these factories so that we can stop this global warming? Why? So he's a critique. Now Remy is going to give him some good answers as to why we need to care about this situation. One, it is not always the doer that suffers the consequences. So there may be some people greedy to get money and they make factories and they cause all this burning of fossil fuels to make products, right? And releasing all this pollution, all this carbon dioxide that is leading to global warming, but it's affecting all the innocent people, the people who are not making these factories, right? So it's important to stop this because the wrong people, the innocent people, are being affected. Secondly, economic imbalance. Okay, what does this mean? So say we have this farmer that is, or there's these two people. Um, one guy starting a company, making factories and stuff, releasing carbon dioxide, and there's like this farmer that's also, doing farming. And now the farmer decides to take measures to prevent carbon dioxide release, and in doing so, he is making less business, right? He is making less money because he's trying to be environmentally friendly. Now, this big company decides to not give a crap and continue their thing. So what this does is it creates an economic imbalance. The people who care are getting affected because they are making less money in the process of trying to help. Whereas the people who don't care are making more money because they get to take shortcuts. Because it's easier to pollute the environment and make more products than it is to try and do it in a more difficult way by trying to take care of the environment. So it creates this problem because the people who care will suffer more because they will lose more money because they cannot make as much product because they don't take shortcuts. Thirdly, environmentally friendly consumers. We can encourage the consumers of the products to be environmentally friendly, okay? To use products that are environmentally friendly instead of products that are damaging our environment. Now, next, scientists say. We always listen to this one. According to science, then everyone believes it, right? So scientists say invest in a sustainable future, prevent harm. So there are many things, health, right? So carbon dioxide is creating health impact. People can get lung cancer from pollution and all this sort of stuff. So according to science, there are many reasons, but scientists say that we should invest in a sustainable future and prevent harm. Now, lastly, leave things as you get it. It's very unethical. If we continue to destroy this earth, our kids or our kids' kids will have a huge issue to deal with because of us, not because of them, because of us, right? So it's very unethical. We have to be responsible and try and leave the earth the way we got it. If not, make it better, okay? So this is just a little argument as to what some people may not understand why it's worth it to stop this global warming. And here's basically some arguments to help sway their minds, okay? You need to understand this, but like I said, it's a bit logical. Like you can't think of these things by yourself, but here's just 5 points for you to remember. Okay, last thing, finally. This one, trust me, you'll think this is not important, but believe me, it is, okay? It shows up on the exam constantly, and I'll show you. So look at this. Here we have two frogs that jumped into a water that's being boiled, okay? Now, basically, the one is saying, we will get out when you prove we will be boiled alive, okay? So the one is saying, okay, we're gonna stay in here, I got to think about this. Sometimes it's confused me a bit. Basically, let's look at this one first. So what this diagram is saying, okay, this is basically a cartoon that's helping to illustrate a point. And this point is, before anyone takes an action to do any kind of thing in our world, for example, start some kind of company or do some kind of act on the environment, before you do that act, you need to prove that it does no harm before you can do that action, okay? So some guy may just be like, oh, that looks like it's going to do harm. You shouldn't do it. They don't need evidence to say that it's going to do harm, but you do. So you need evidence to show that it's not going to do harm before you can start it. But the person saying that it's going to do harm does not need evidence. Okay, so that's kind of what's happening in this picture here. This guy is saying until we have evidence, we shouldn't do this. Okay, that's what he's saying. Until we have evidence, we should not do it. Okay, which is exactly what the precautionary principle is. Okay, here we have it. So if the effect of a change caused by humans may be harmful to the environment, action should be taken to prevent it, even though there may not be sufficient data to prove that the activity will cause harm. Okay, so even if there's not enough data to prove that the activity will cause harm. Now, again, this doesn't matter much. You can read that, but you need an example. So for example, let's say let me just show you this before you click away from this video, because you may not believe that's important. Here's an IB question that literally says outline the precautionary principle, and it's 6 marks. So you need to get 6 marks from this question. And the first few marks you can get just by defining it and describing what it is, and then you need to have an example of application of this principle. So I'm giving you one here. So say we have a certain species that we want to introduce to a new environment. We want to put in that environment. Some guy might say, what if we put those species in there? What if they kill all other species? And you might be like, that's true, it may. So until you can prove that it will not cause that problem, you're not allowed to do that action. So until we can prove that these new species that we want to put in that environment, until we can prove that they will not cause harm, we're not allowed to put them there. Okay, so that's kind of how this concept worked, how this precautionary principle worked. Basically just being precautionary, not doing anything, not taking risk, being sure about something before it's done. In this way, we can kind of try and reduce the impact we have on the environment by having certain impact and certain things that we do to the environment. So that ultimately is it, and I hope you learned enough in this video, and this is really it. It's all you need to know. I hope it was useful, and I recommend you doing some more IB questions like this one here, and you should be all good to go.